Hello class, I just wanted to let you know how to use, control, and diagnose problems with your servo controlled by a potentiometer. So let's go ahead and see what parts I need. I need my servo, I need my potentiometer, several wires, my Arduino board, and the cord itself. So just to show you what should happen when your code works correctly, when I turn the potentiometer, my servo turns the same way that my potentiometer turns. And eventually we can use that to control the strings on the actual robot hand itself. So when you turn the potentiometer, it pulls the string back, pull, and then it moves the fingers. So I think that's going to be pretty cool. As far as the big things you need to know for this lesson, the servo itself has a brown wire, a red wire, and a orange wire. Well, brown is like black. That goes to ground. So I look at the brown wire, and I plug the brown wire into the ground. I plug the red wire into the positive, and the signal wire is this orange wire. I plug that all the way. For this code, I plug that into slot 9. So let's go ahead and see where that is on the code. I have mine as line 7. I am defining the servo pin as connected to number 9. So in here, I'm also defining what the potentiometer is plugged into. I'm plugging it into A0. So let's just make sure I'm doing that right. I have A0 right here. Let's follow that along. And I have that actually plugged into the middle of the potentiometer. The middle is where we control where the signal for the potentiometer actually comes out. To note one side of the potentiometer, notice how the little pin right here is plugged into the negative, and on the other side, that other side pin is plugged into the positive. The signal wire again comes out and plugs directly into that A0 pin. And it's A0 because that's what I define. Note that I'm using a servo. Your program doesn't know how to use servos yet, so I have to do what's called include it, this library, into the Arduino. So I'm adding how to control servos into it, and I'm defining the servo I'm going to use as servo 1. Then I'm saying I'm plugging in the potentiometer that will control it into A0. I'm defining the pin the servo will be plugged into to number 9. And I'm also need to define this thing called a value that I'm going to be changing later. The only setup is the only thing I'm using. I'm only using a servo, so I'm going to attach that servo to pin 9. I can actually just replace this by saying, instead of saying 9, I can say servo pin. And now if I change this number at any point, it automatically changes this number. So I think that's pretty cool. Then in the loop that's running on forever, that value that I defined earlier will read whatever value the potentiometer gives. And then this is the cool function that's next, is whatever this reads, turns out analogs are numbers between 1 and 1024, but if I include 0, that's between 0 and 1023. The reason for that is it's 1 bit, and a bit is 2, and it can be a 1 or a 0, a 1 or a 0, and a bit is 8 of those. So it's actually 2 different options times itself 8 times, or 2 to the 8 power. You'll learn about why this is the case later in life. But not only that, but why this matters is I'm mapping all the values the potentiometer can be, 1 to all the values the analog can be, which is a bit, 0 to 1023, to all the angles the potentiometer can be at, which is 0 to 180, or no circle to half a circle. Then I'm going to tell the servo to go to that value, and then I'm waiting 15 milliseconds for the next value to be read. So it's reading what the potentiometer says, moving it to an equivalent angle, telling it to go to that angle, and then I delay. Then I repeat over and over and over again. So I hope you enjoyed it. Remember, all that's going to be happening is you move the servo, you move the potentiometer, you move the servo. I hope you have a good day.